The Flex feature can be applied to any solid body, whether it was designed in SolidWorks or imported from another CAD system. In this case, I'm working with an imported model. Notice there are no features listed in the Feature Manager tree other than a single imported body. The Flex feature icon is not found on the Features toolbar by default. You can add it to the toolbar or access it from the Insert, Features drop-down menu. When the Flex feature is launched, as with other features, a Property Manager will appear, allowing me to define the parameters of the feature. The first item to define is the solid body that I will be applying the Flex feature to. When it's selected, a few things appear in the graphics window. 2 trim planes are shown, 2 axes and a triad. Understanding the role of these items within the Flex feature is the key to being able to use this feature intelligently. First of all, let's talk about the trim planes. By default, they appear at the extreme ends of the solid body you selected. Any region of the solid body that lies between these planes will be affected by the Flex feature and potentially be deformed. This is important to know, especially if there are regions of your model that you do not want to change. The position of these planes can be adjusted by dragging the arrows in the graphics area. The planes can be rotated by clicking and dragging their edges. You can also use a distance value through the Property Manager. This distance is measured from the extreme end of the solid body. In other words, setting this distance to 0 places the trim plane at the end of the model. You can also position trim planes precisely by selecting a reference vertex. You do this by activating the selection window for the appropriate trim plane and selecting a point vertex in the graphics area. Before we actually deform this model, let's take a look at the role of the triad in this operation and also look at how to manipulate it. I'll return the trim planes to their default position to make it easier to see the triad. The triad provides a point of reference for the Flex operation. It acts as a coordinate system that defines the center of the Flex operation, the orientation of the trim planes, and the direction of the axes. There are several ways to manipulate the triad. The simplest is to simply drag it. You can drag the blue point to move the triad freely in 3D space. Or you can click and drag the individual arrows to move only along the direction of the arrow. If you click and drag a rotation ring, you'll rotate the triad about the ring you've selected. Notice as I do this that the orientation of the axes and trim planes rotates as well. Also, you have some options that can help you when rotating the triad. If I right-click on a ring, I can select Snap while dragging, which will snap the rotation angle at every 90 degrees. I'm also given the option of Rotate 90 degrees and Rotate 180 degrees, which will automatically rotate the triad for the selected value. If you wish to control the location and orientation of the triad more precisely, you can enter numerical values in the Property Manager. Notice there's a selection window where you can specify a coordinate system to use as a reference. If you leave this blank, the coordinates are in reference to the part's global coordinate system. The position of the triad is critical to the outcome of the Flex feature. There are some helpful shortcuts available that allow you to position the triad based on other items. First of all, if I right-click anywhere in the graphics window, I'll see the option to Reset Flex. This returns the trim planes and triad to their default positions. Now that you've learned how to manipulate the trim planes and the triad, I'll go ahead and show you how to define the 2 axes. First, you must know what each axis represents. The blue axis is the trim plane axis and always aligns the trim planes perpendicular to it. The red axis is called the bend axis, and this is the axis which the part will bend about. Note that both axes correspond to their colored arrow. So to define each axis, you must right-click on the corresponding arrow and select Align with Selection. This option allows me to line up the axis to an item I select. If I select a planar face, the direction will be normal to the face. If a line or edge is selected, the direction will be along the selected line or edge. If a point is selected, the direction will be along a line that connects the point to the part origin. You may have noticed that I can also choose to move to selection. This option will not only align, but move the triad to the item I select. If I right-click on the center of the triad itself, I get several more options. We are once again able to select Move to Selection and Align to. A word of advice when using these options: I find it easier to use the method we just discussed, right-clicking each arrow to define the axes separately. Center and Align to Principal causes the triad to be positioned at the centroid of the part and aligned to match the principal axes of the model. The last two options provide a convenient way of aligning the bend axis, the red one, to either of the trim planes. In a moment, we'll see why this can be very useful. Hopefully now you have a better understanding of the roles of each of the elements of the Flex feature. In the next lessons, we'll use the Flex feature to deform several parts so you can see the effects of the many options we discussed here.